Swayam Prabha. Digital India. Educated India.
Welcome to Module I, Lecture 3. In this lecture, we shall discuss about Blackspot analysis. In Lecture 2, I mentioned to you about what is road safety engineering and what are the different ways to deal with the road safety issues. Then why we need crash data, what we expect from good crash data, what all we can do if we have good crash data, then about the crash data collection system, what was the traditional approach and what are the modern trends for crash data collection and database development. So, now you have the data, right. So, you have the good crash data, that database is available with you. The next is Blackspot analysis. So, first about a background, what is Blackspot, why we need to identify Blackspot, and then what are the different methods or techniques that can be deployed to identify black spots. Scientific relationship between the crash frequency and severity, it might be frequency, the number of crashes, or the severity, how many are fatal crashes, how many are major injury crashes and so on. That is on one side, and the traffic volume and other variables on the other side, and there are scientific relationships. Relationships between what? Between crash frequency or crash severity and the traffic volume and other variables. Now, individual crashes are random. It is always we can say the what type of crash or whether a crash will occur, it depends on so many things, and obviously, it can be described as a random variable and therefore, can be expressed only in terms of or with the help of probability. So, individual crashes are random and can be difficult to evaluate, but then safety analysts have developed a number of methods for identifying problematic sites or problematic road segments. It could be problematic sites or problematic road segments for further analysis and necessary improvements. So, not all segments are same, not all sites are same, some sites or some segments have got genuine road safety issues as reflected in the database. So, these methods are to identify such problematic sites and road segments. Once, so the identification is the first step. Once we can identify, then further analysis can be done. You know that these are my problematic segments. So, we can always go and try to understand more why it is so or why they are problematic, and then accordingly suggest necessary improvements. Now, these sites should represent the shortest segments of road sections with a given set of homogeneous characteristics, at which the estimate of the expected or actual accident frequency is the largest or generally higher than what is acceptable or higher than those in other segments. So, identification of sites or such segments, as I mentioned, is the most fundamental and crucial steps, since improper identification of high priority sites results in less cost effective solutions. That means, if we are able to correctly identify the most fundamental or most problematic sites and then treat those sites. So, if we can identify the most problematic sites, correctly identify them and then treat those locations or segments, then maximum benefit will go to the community. So, in a way, it becomes more efficient. So, identification of site segments is the most fundamental and crucial step, since improper identification of high priority sites results in less cost effective solution. So, if I can really identify the most difficult and most problematic sites properly and treat them, I can say that I am able to give a return maximum benefit to the community. Now, these high priority sites are generally referred to as sometimes black spots, sometimes they are called high crush locations, sometimes they are called hazardous locations, etc. Now, how we can then we understand why we need to identify black spot and what is black spot, but then how we can formally define black spot. So, black spots is the general term used to recognize a hazardous location based on accident frequency and or crash rates. You can say. Now, these are the sections of roadway that are designated as being accident prone. If we are when we are driving, we often see that police boat, this is accident prone, right, this location. Now, how we identify? If we can identify, if we can inform users, then they become more careful also. So, black spots is a general term which is used to recognize a hazardous location based on accident frequency and crash rates. So, these are the sections of roadway which are designated as being accident prone. Ministry of Road Transport and Highways, Government of India, they have said something how to identify black spots. In some way I will say, you will see the other approaches we will discuss mostly relative, right, and here this is more of in absolute terms. As per the black spot definition as given by Ministry of Road Transport and Highways, road accident black spot is a stretch of national highway of about 500 meter, in which either 5 road accidents in all the 3 years under category fatalities or grievous injuries, involving fatalities or grievous injuries took place during the last 3 years, or 10 fatalities in all the 3 years put together took place during the last 3 calendar year. So, first of all, this definition is based on past 3 years data, that is number 1, and divide the road into some homogeneous sections approximately 500 meter length, and in the last 3 years either the site experienced 5 accidents involving fatalities or grievous injuries, or the site experienced 10 fatalities during the last 3 years. So, first one is number of accidents, and the second is, or that is the number of fatalities. 5 accidents of involving fatalities or grievous injuries, or 10 fatalities in the last 3 years. Now, all the data to be provided by the police authorities or National Crime Records Bureau. When we are talking about crashes, then the severity is very important. Crash can broadly be classified as fatal crash, non-fatal crash. Fatal crash means at least one person died immediately or post hospitalization. It may be that a person died immediately or maybe after transfer to hospital. So, post hospitalization, and at least one person. So, at least one death immediately or post hospitalization, that we will call as fatal crash. If there is no death, then we will call non-fatal crash. Non-fatal crash can be again divided into 3 classes: grievous or major injury. So, lot of that is probably the highest, where hospitalization is required. Minor injury crash, where only minor injury happened, no hospitalization is required. The third, no injury or property damage only. That means, okay, it goes and hit a small house or some shop or something which got damaged, property got damaged, but no injury, no death happened. So, non-fatal crash could be major injury crash or grievous injury, minor injury or no injury or just property damage only. Now, let us look at the different techniques which are used for identification of accident black spots. Identification of sites or segment is the first and an important step in the process of road safety improvement. Based on the data, we want to know where the problem exists, location specific. And as I said, that accidents can occur due to, or crash can occur due to so many reasons, and these are naturally to be randomly distributed, right. But do we really find that at some location distinctly high or higher number of crashes are happening at certain locations as compared to other locations? That tells you probably there is something wrong with the location, or there could be location specific problem which are contributing to so many accidents or so many fatal accidents or so for at certain geographic locations or certain short segments. So, we need to identify those segments, and unless we identify correctly, our treatments and the overall investment will not be able to bring or get maximum benefit out of the investment. The smallest length of a road stretch with homogeneous characteristics, which is associated with the maximum expected value of accident frequency, and for doing that we can divide the road stretch into small segments. If you have very good data, and so you can even make 100-meter segments, or you can take even half a kilometer or 500-meter segments, or even 1 kilometer segment also, right. Be careful and look at the thing at what accuracy the data is available, or with what accuracy the database is developed, make things compatible. Now, some of the basic and popular techniques are for identification of black spot obviously, and these techniques are crash frequency method, fatal crash frequency method, equivalent property damage only method and upper tail critical test method. So, I am going to discuss these 4 techniques very briefly. First, crash frequency or total crash count method. It is called CF or TCC method. What we are doing? We are using the crash counts or number of crashes. You have divided the roads into small homogeneous, multiple homogeneous sections. For each section, we want to see maybe last 3 years, how many total crashes occurred. Somewhere you will find 0, somewhere 2, 5, 7, 3, right. Just look at the total number of crashes that occurred over the last 3 years in each segment. Then based on the number, we simply rank the sites in descending number of crash count. Top segment or location or segment with the maximum number of crashes in the last 3 years, followed by the next highest like that. So, the site with maximum number of counts receives the highest rank, that is we can call it as rank 1, and the locations with top 10 ranks, when you are taking maybe hundreds of such segments, the top 10 segments you can easily consider as the black spot, or you can consider that the higher numbers are higher in those segments as compared to others. So, you can maybe top 10 or top 20 such locations you can take. Now, CF method, or when you are using crash frequency, it is useful in detecting sites having high frequency of crashes, because total number of crashes you are considering, nothing else. But then it fails to consider the crash severity, because you can always argue that maybe 2 locations same number of crashes are happening, but in one case more fatal crashes are happening. So, I should have higher priority to that logically. So, it fails to consider that aspect, because you are using only crash frequency or total crash count. So, you are not able to consider the crash severities. So, as a result, a site with relatively less number of total crashes, but with higher fatalities may not be detected as a black spot. It may not come in the top 5 or top 10 or top 20, may come, may not come also. Now, to overcome this difficulty or the drawback, another method is suggested, where we are using fatal crash frequency or fatal crash count. Instead of total crash count or crash frequency, we are using fatal crash frequency or fatal crash count. So, only fatal crashes are considered, number of fatal crashes. So, this method uses fatal crash counts as opposed to total crash counts, and the sites are arranged in descending number of fatal crash counts. Again, this has got a limitation. The good thing is, yes, fatal crashes are most important. So, I am considering that, but I am only considering that, nothing else. So, that means the limitation of this method is its inability to assign any weight to non-fatal crashes. I am not assigning any weight to non-fatal crashes. I am considering only the fatal crashes, nothing else. 0 weightage to non-fatal crashes, grievous injuries, minor injury, property damage, I am not at all putting any weightage. Let us take an example. consider the crash data as given in the table and identify 5 most hazardous locations or black spots using crash frequency and fatal crash count methods CF and FCC. So, I have both chainage wise, here I have taken 1 kilometer segments. So, 0 to 1, 1 to 2, 2 to 3 like that. Here the data is given up to 15 kilometer every kilometer. The crash frequency is known, total number of crashes, and the fatal crashes are also known. So, what I will do? I want to find out black spot, first 5 most hazardous locations using crash frequency. So, based on crash frequency only, I will arrange the chainages and identify the top 5. When I want to use FCC method, then based on fatal crashes, I will sort the chainages, I will arrange the chainages as per the fatal crashes, highest number on the top, lowest number in the bottom, and then top 5 chainages I will pick up. That is what I have done. So, here you can see using the crash frequency I have sorted out the, I have done the sorting. So, chainages 3 to 4 16 crash frequency, 11 to 12 13, 14 to 15 13, 2 to 3 12, 13 to 14 12 and so on, right. So, the first 5 or 6 whatever you want you pick up. When I am using fatal crashes, FCC fatal crash count, then as per the fatal crash count we are rearranging or we are sorting the chainages, sort the chainages based on this fatal crashes, number of fatal crashes, and highest on the top, lowest in the bottom, and accordingly again you take the identify the top chainages, 5 chainages or segments, 5 segments. Incidentally, you can see here maybe just coincidence, but 3 to 4 this chainage, it is number 1 based on crash frequency, also number 1 based on fatal crash count. So, sometimes we use different methods and check that whether a particular chainage is coming again and again appearing within the first 5 or first 10 depending on how many segments you have. Whether these some chainages are appearing everywhere, that indicates that no, it is not once, but it is coming again and again. A chainage, a particular segment got recorded the highest number of crashes, also the highest number of fatal crashes. So, that tells you this you must look into, you must consider this as a black spot. Third, we know the advantage and disadvantage with the first one when I use the total crash count or crash frequency, and also I know the second approach when I use the fatal crash frequency. Now, further improve, okay, I want to consider all types of crashes, but I want to give different weightages to fatal crashes, grievous or major injury, minor injury and property damage only. That is what is the method what we called as EPDO, equivalent property damage only method, EPDO. That means, all crashes we are considering and converting into equivalent number of property damage crashes, right. As we use the concept of passenger car equivalency or passenger car unit, a bus equal to 3 cars, right, a light commercial vehicle equal to 2 cars, like that, similar factors we want to use and convert all types of crashes to an equivalent number of property damage only. So, consider all levels of severity of crashes occurring at a particular site or stretch. The total accident for each site is expressed in terms of its equivalent property damage only or EPDO. The number of the property damage only crashes, number of fatalities, number of major injuries and number of minor injuries for each site are multiplied by their equivalent property damage weight factor. This is something like passenger car equivalency, and then added together to calculate the EPDO for each site or stretch. For the calculation of EPDO weight factors, the cost of various accident types may be taken suitably by the analyst. On an average, what is the cost? What is the loss due to a property damage crash only? What is the average in economic sense? You can, separate studies required to calculate all this based on the past crashes, evidences, interviewing, surveying the people, what is the real economic loss to the family, and various factors you consider. It is not like that we are trying to value the life in terms of money, right? You cannot value that. If a fatal crash occurs, it is enormous loss. You cannot quantify with equivalent, but it is for the scientific analysis purpose we want to give lot of weightage to that. So, as compared to property damage, we need to understand assign a value to that, right. For example, a study which was carried out by TCS way back in 99, they worked out the cost. What is the average cost? Property damage 16,200 Indian rupees. Compared to that, a fatality is 5 lakh or 535,489, right. So, 33 times it was taken, right. So, it was for this purpose that when we are doing the analysis, we want to assign more weightage to fatal, then major, then minor injury, and then property damage is 1. Convert everything into equivalent property damage only. So, based on this cost estimate, it was carried out using a separate dedicated studies. So, such kind of studies can be done, and based on that, as in Indian scenario, these are the EPDO weight factors which were developed based on this TCS study. So, property damage 1, minor injury 1.16, major 15, fatal 33. So, every time I am taking a fatal injury is happening, a fatal accident is happening, one person is dying, I am putting 33 times higher weightage than an accident or crash where only property damage is happening. That way giving higher weights. Obviously, highest fatal, then major injury, then minor, then property damage. Property damage is taken as the basic unit. So, always considered as 1. Now, consider the following crash database as given chainage wise, again the fatalities and major injuries, minor injuries, no injury, all are given. So, now if I want to use a EPDO method, what I will do? I will do it fatal, let us see that. What I will do? I will take the fatal 1 multiplied by 33 plus 2 major injury multiplied by 15 plus minor injury 1 multiplied by 1.16 plus 3 no injury, that means only property damage. So, 3 into 1. So, 67.16. Like that, for every segment I can calculate the EPDO value, and then I will rank the site as per EPDO. The highest will be top, ranked 1, followed by next maximum value, right, and like that I will get the sites number 1, number 2, number 3, number 4, number 5, like that. That is what I have done. And you can see here 171.3 is the highest value among this. This is example problem only. 15 chain edges, 15 segments only we have taken. So, out of this 15, maximum value you got 171.3. So, that is ranked as 1, followed by next highest is 148.6, ranked as 2. Third highest is 148.3, very close, but slightly lesser. So, ranked as 3, like that the sites are ranked. So, all types of crashes we are considering, but we are also not giving the same weightage to all crashes. Fatal giving higher, then major injury, then minor injury, and then one value is assigned to property damage only, and everything we are converting to property damage only using factors which are very similar to like PCU. We have to convert heterogeneous traffic to a stream of equivalent stream of homogeneous stream traffic, similar kind of thing we are doing. One more method that is also used, quite acceptable, even I will say more scientific, is the upper tail critical test. What is the assumption here? The crash frequency or EPDO values follows standard normal distribution. Every segment you take, the number of crashes or even the EPDO values, it is assumed that obviously it is expressed as a random variable, right. So, it will follow the crash frequency or EPDO follows standard normal distribution. The normal distribution, it is always random and described by a distribution, suitable distribution, but what is assumed that it is following normal distribution. And then upper tail critical value is computed using the mean, standard deviation and the z value at a specified significance level for identifying the black spot. So, what is that upper tail critical value? Upper tail critical value is mean plus 1.645 into standard deviation. Now, is 1.64 is the value of z at 5% significance level. So, if you consider a different significance level, you may get a different value here. So, so this is the critical value. That means, any chain edge, if having a crash frequency or EPDA value more than the critical value, upper tail critical value, then we shall consider that particular segment or location as black spot. So, that is what is. So, this method is used to identify roadway sections with the observed EPDO or CF values exceeding the calculated critical value, and this critical value is upper tail critical value, right. So, that is what it is. So, if I take an example, suppose the chain edges and the crash frequency and EPDO values are known, then and I want to use upper tail critical test method. So, simply I am calculating the mean and standard deviation in the case of crash frequency and also with the EPDO column, and then I am calculating the upper tail critical value for crash frequency, which is what average is mean is 9.27, standard deviation is 3.43. So, 1.645 into 3.43, that is 14.91, and upper tail critical value for the considering the EPDO values, mean is 88.67 plus standard deviation is 46.35. So, 1.645 into 46.35. So, you are getting actually 165.91. So, now I will search, let us say crash frequency, whether I have got any value which is more than 14.91, and you can find you have got only one location where the crash frequency is higher than the upper tail critical value. So, only that will be recognized as a black spot, no other location. Similarly, if I look at the upper tail critical value for EPDO, it is 165.91. So, I have to look at this column and see whether I have got any segment where this EPDO value is more than 165.91, and I find again 3 to 4. That is the only black spot, and incidentally this case probably is the same data, I do not remember. So, this chain edge 3 to 4 or this segment is the identified as the black spot based on the crash frequency and also EPDO when we are using the upper tail critical test, right. So, there must be something wrong here. We should then in the next stage of work, when we say that what we do and how we do, right, we should investigate further that location we have identified now and then try to get the countermeasure. So, what I discussed in this lecture, I told you why we need to identify black spot, how the black spot is generally defined. I will say again, the proper definition is where statistically more number of crashes are fatal, total, EPDO, whatever way you say, more number of statistically higher number of crashes are happening as compared to other locations. But then there are other definitions as well. People use crash frequency method, people use fatal crash frequency method, people use equivalent property damage only method and simply rank the site and take depending on how many sites segments you have 100, 250 and then accordingly they decide first top 5, top 10, top 20 locations, that is also people do. Upper tail critical test is more statistically we are trying to see, right, that 5% significance level, what is the with 5% significance level, what is the value of critical value, right, upper tail critical value considering the mean and standard deviation. So, that way also we do very scientific, and also there could be absolute thing, right, the MORTH, Ministry of Road Transport and Highways, and as it says, let us go back to that slide once again before I close, that 5 road accidents in the last 3 years, and these are accidents of what type? Involving either fatal or grievous injury, either fatality or grievous injury, or altogether 10 fatalities occur based on the last 3 year data. But there are always alternative things, as you know, you can say all road types are same, no, different traffic road will have different volume, different terrains, right, divided road, undivided road depending on volume, depending on type of vehicle, so many variations are possible. So, I am sure further and further works will happen and we will come out with maybe even more rational way of quantifying the black spots. With this I close this lecture. So, thank you so much.